So thank you, Alisa. I'm very excited to be here. And I want to start with something, web applications. We are all web developers, yes? Yeah, of course. And we start to develop our applications, and our users have a lot of expectations from us, that the applications will be very, very performant and sometimes work offline and do some great stuff. So we build the application and we ship it, and we are happy. And then the first user comes to our application, and the second one comes to our application, and they're stuck with the loading. And loading is so slow, which leads to frustration, And then they try your app. It loaded, and they're starting using, and they're using navigation in your application. Or use some drop-down list, and it works perfect on your machine, but on their machine, sometimes it quirks. Or maybe a toggle. And all we wanted to do is to ship the best app that we can, and our users love our app. We want best apps, but best apps are probably applications that not only work on your machine, but perform well on the user's machines. And users use more than just desktops like we do when we develop. They're using mobile phones and tablets and et cetera, and these devices have different CPUs and different ways of running your application. And this is the talk that I'm going to present to you in the next 27 minutes, which is how to profile your application in order to performance tune your application. So Alisa told you a lot about me. I'll just rephrase it quickly. I'm sparXys CEO. I'm both GDE and MVP, Microsoft MVP and Google GDE. I wrote a book called Pro Single-Page Application Development back there in 2014. You can use it as something that will make your screen more taller. But it gives you the content of how to develop good single-page applications, but with backbone. Angular Conference, backbone. OK, let's move. And I wrote some Microsoft official courses that can be learned in Microsoft's learning centers across the world. So if you did the HTML5 programming course by Microsoft, go to the 7th page, and you will see my name there as the author. What we're going to do here is the following. First of all, I'm going to talk about how browsers render your applications. This is a very crucial thing, because once you know or understand the process, you will know how to figure out some things when you are profiling. Then we'll go and profile some Angular applications with problems, and you will see how I work in order to go back to your place at work tomorrow and then do profiling and find performance bottlenecks. So let's start with understanding the browser rendering process. First of all, as I said, we have devices, and all the devices' refresh rate is 60 times a second, meaning we have 60 frames per second in each and every device that we are using. That means that you have only 16 milliseconds to ship every frame. And to make it much harder, each and every browser has some work that it needs to do. So in reality, a frame should be below 10 milliseconds because of the browser overhead. And if you are doing less than 60 frames per second, you will get junk. Junk with A, not with U, even though junk and junk, it's the same, okay? With performance. Your performance will be bad. Now, each and every browser ships the frame to the screen in the following process. This is called the pixel pipeline. First of all, JavaScript. The JavaScript will handle the work for you for every interaction that the user is doing, and it will run some stuff that you're doing in order to create visualization or visual changes. These things also occur when you change CSS transitions or use CSS animations or web animation API. The second step is the style, okay? But the browser figures out, according to your CSS selectors, how to draw the elements in the page, meaning draw in the content of the elements and where the elements should be, okay? Then the browser understands where the elements should be, and the layout step is starting. This is the most crucial step. It organizes the whole page, so if you see some changes during the loading where elements move from one place to another or things like that, this is problems with layout that you caused in the application. So this is applied according to the web layout model, the box model. I hope that you know that. If not, go and read about the box model later on. The fourth step is the paint, meaning that the browser paints the pixels to the screen according to the color that you set style, according to the place that the element needs to be, and etc., etc. The last but not least step is the composite. The composite is the step that, you use z-index sometimes. So the browser needs to understand if there are overlapping elements and place one element on top of the other. Okay, this is the last step, and this is the whole pixel pipeline. Now, when we're talking about pixel pipeline, we're talking about reflows. What is a reflow? A reflow is a process in the browser that the browser, according to some visual change, need to calculate the entire layout again. This is a very expensive process, and the whole pipeline, the pixel pipeline, will run again. You want to minimize this process. A repaint occurs when a visual change doesn't require the calculation or the recalculation of the whole layout. That means that you change some color, red to green, then all the pipeline will run again without the layout, which is expensive. But the painting is also expensive. Reflows and repaint, please minimize the effects. Changes to the DOM, changes to colors, etc., should be bundled together, okay, in order to create better performance. The last option is that we have a process that doesn't include repaints and reflows. That means that you're changing something in JavaScript. For example, you have some timer that runs and calculates some calculation, which doesn't affect the DOM or the CSS or the style. Okay? So these things happen. Then the process will run, but only with JavaScript, style, and composite. Now, when you start working on your application, start thinking about the Rail model. What is the Rail model? It's a user-centric performance model. Rail means response. Each and every event should be responded below 50 milliseconds. Animation. You should produce the next frame in 10 milliseconds. If you're going more than 10 milliseconds, you're doing wrong things. Idle. We are developers. We sometimes love the laziness. So make the application lazy, okay? As much as we can, we should maximize idle time, okay, to be responsive. And load, meaning deliver the content under 5 seconds, okay? We won't discuss how to deliver content under 5 seconds. There are good sessions around the world. Go to Adios Mani's sessions about how to do lazy loading and etc. And you will understand how to make your application interactive under 5 seconds. So now, after the background, let's start profiling. How do you do profiling in web applications? DevTools Performance Tab. Who opened the DevTools Performance Tab in the last week? Please raise your hand. Wow. OK. So the people who didn't raise their hand right now, you'll probably learn something new, or you not. But let's start with a small demo. God bless you. OK, so here is an application that I have that prints some colors. It's an Angular application. Let's open the DevTools. And what you can see here is the Performance tab. In order to record the performance of my application, I would just need to do Control-E or press this button on this button. Let's press it, and let's do a refresh. And let's stop it. Now, we get a timeline with a lot of details. Don't be afraid of those details, OK? This is the first thing that you need to understand. Those details are very helpful, but you need to understand what they are telling you. For example, what I can see here is that the entire loading of the page took around 4 seconds. OK, that's good in the Rail model, but that's not such a good thing if we're talking about an application that draws just some color things on the screen. Another thing here is that I can use these handles to minimize my view or maximize my view in order to understand things here. I can look at the timeline here, and I can see here a lot of details like frames or what happened here. There was a very long task, the loading of the application, and it resulted here in the onload event, the DOM content loaded event, first paint, and first contentful paint. Okay? Now, we're talking about profiling, and there are a lot of details here, but what I'm going to show you is that we can go and look at the summary of the whole thing here. Okay? We have 2 seconds of scripting here. The loading took 7 milliseconds. The rendering took 8 milliseconds. So we are doing a lot of scripting right now. If you are doing a lot of scripting, that means that there is something problematic in the code. So how can you understand where are the problems? We can go to Bottom-up tab here, and we can look at the total time, and we can dig in and see things. For example, the bootstrap here from Angular took some time. There is the main TS that took some time. These are from the Angular, and I can assure you that the Angular code is very performant. We will continue and search for things or problems which might arise here. So I have a component here, the color component, that took some time to load. And we can see here that there are 2 indications of problems that I need to check out. For example, color component in the ng-on-init function and color component in the decimal to hex function. Let's take a look at decimal to hex. And once I click this link, I can see a lot of details about things that took a long time. For example, this line of code took 1 second. It ran a lot of times, and all the times that it ran, it produces some string, and it produces it in 1 second. That's not a good thing. Another thing to notice here, don't take console log to production. Look at it. 195 milliseconds wasted because of console logs. Okay? So one tip, remove console log when you go to production. So let's take a look at the application itself. Here we have the colors page, and this is the color component. And once we are doing profiling, we are like a detective. We try to understand what we wrote, to understand how it performed on the screen, and then to make assumption of how to improve our performance. So I have a function here called decimal to hex. The function is calculating a number and transform it to hex form. And I'm using that function here in the component itself to set some background color. So I'm setting the background color here with that function 3 times. And a better solution, which will produce better results, will probably be something like this, okay? Just use the RGB function that is part of the CSS spec. We didn't know that, but now we know that there's something that exists that is better than better than our own calculations. So this is something to remember. Not all the solutions that you are using are the right solution for performance. Okay? Now we can go to the profiling here again, to the app. Go to the performance, clear it, run it again, refresh the page, stop, and look at the results right now. Okay? So let's see if we have a change. Nope. Well, I'm scrolling and scrolling and searching for that ng on init. It's still here, okay? But the decimal to hex performance is better. And the ng init is better. It didn't took 4 seconds, it took 1 second. We can do better. I can remove the console log and it will run super fast, okay? But these are the things that I try to teach you, okay? Sorry for that. So how does the process of profiling works? We establish a baseline, meaning that you will open a browser in incognito mode. Why is that? You don't want all of your extension running and doing some stuff and affecting your profiling. You will collect data using the Performance tab. Then you analyze the results. You will try to find some places in the bottom-up, for example, view, in order to see if there are wrong things that we did. Then you make the assumption and you tune up your code. And you test and measure the code again. If that works, cool. If it's not working, then you collect the data again, analyze the results, tune the app, and test and measure, and etc., etc. This is the process, and I hope that you will start doing that process during development time and not on production. So let's profile another application or another web page here. So in this app, I have another page called Movies, and it has a problem. One major problem. If I want to change the title and just add a random number to the title, I want to press the button and that the number will appear very fast because it's just concatenation of strings. But it's not appearing very fast. There is something wrong here. So let's profile it and let's understand what is going on. Okay? So I can profile, change the title, wait, and wait, and wait, and wait, because profiling has some overhead, and stop. Now, we have the results here, and I can go to bottom up and try to understand what happened or what are the problems. Sometimes Chrome developer tools are very smart, then they will mark the problem for you. Okay? You won't need to dig in and to understand what's going on. So movie.component here is doing something that is wrong. Now, in this page, we have a lot of movies inside of a movie list, and that movie list is problematic. Why is that? Because, let's take a look at the code here. Each and every movie here has change detection default. That means that ng-check will run for each and every component, movie component, even though we just press a button on the movies component and we want to change something there, okay? So, of course, the solution for that will be on push, okay? But now you probably understand what is going on, okay? Why we are using on push, okay? If the component isn't going to change and it's just a rendered component, then it doesn't need to, or it's not supposed to run or to affect our performance in the web page. Okay, so I can change here the default to on push, and you will see the changes, and everything will work much faster. Another step or another thing about profiling is memory leaks. A memory leak is a memory that you use, or application use, that isn't returned to the memory pool. That memory isn't freed by the application. It gets stuck in memory. The memory gets stuck, and what happens is the memory of the application starts to decline until you don't have any memory and the application crashes. And JavaScript has memory leaks that has memory leaks, but you can create memory leaks with JavaScript, okay? Accidental global variables are something that can cause memory leaks, but easily resolved with linters. Just check that you don't have globals. Forgotten timers and callbacks are another thing that can cause memory leaks. Out of DOM references, you put some element out of DOM that includes some references to it, and boom, you have a memory leak. And closures. We all love closures in JavaScript, but a closure is a function that, it's a variable inside a function that finished running, and that variable is kept alive. Okay, so in potential, closures can cause memory leaks if you are using tons of closures and you are not releasing them. Let's talk about Angular and memory leaks. So I have here the same in this application, an example of a memory leak. You have here a number of subscriptions. We'll take a look at the code in a minute. I'm moving to a second page, return to the page, and we have 2 subscriptions, even though we thought we have 1. Why is that? So we start with the lucky service. Okay, this is from Trilo. Go to this link. You will see the same example. Hopefully, you will get the understanding of what I'm doing here, because I don't have much time. So this is a service that exposes an observable, okay, for some random number. And in the component here, what we are doing is subscribing to that number, and then we change the number accordingly. We can see here the number changes. Okay? And what we are forgetting to do here, because we use the service, is unsubscribing. Meaning that once we navigate from this page to another page, we still have the subscription live. And then, once we return, we will have 2 subscriptions in the page, and et cetera, et cetera. What's going to happen is the memory will be flooded with a lot of subscriptions. So how can we fix that? Of course, we can implement the ng on destroy and do unsubscribe to the subscription. Okay? But beware that observable can help you create memory leaks. So please unsubscribe from them in your applications. So let's summarize. Our users expect very, very fast and fluid applications. What I'm suggesting is that you will add performance tuning processes during your the development time and find junk with A before you ship your application. You can profile the application using the Performance tab in Chrome Developer Tools, and you can understand how to create or how to find memory leaks by understanding how things are running inside your application. Don't wait for your users to complain about performance. Tune them today. Thank you.